When one product is late, most people think the problem is simple. Maybe the truck was late, maybe the warehouse was slow, maybe the supplier made a mistake. But in supply chain, one delay is rarely just one delay. A late truck can stop a warehouse. A stopped warehouse can delay a store. A store can disappoint customers. Disappointed customers can reduce sales. Reduced sales can affect future orders. And future orders can change what suppliers produce next. So one small problem can travel through the whole system. That is why supply chain is not just a chain, it is a connected system. And this is where systems theory becomes important. Most people study supply chain by looking at separate parts: procurement, warehousing, inventory, transport, delivery, returns. But systems theory tells us something deeper. It says you cannot understand a system properly by only studying its separate parts. You have to understand how those parts connect, affect each other, and work together. In simple words, systems theory means everything is connected and one part can affect the whole. Now imagine a human body. The heart, lungs, brain, stomach, blood, muscles, and nerves are different parts, but they do not work alone. If the lungs stop working properly, oxygen reduces. If oxygen reduces, the brain and heart are affected. If the heart slows down, blood flow changes. If blood flow changes, the whole body suffers. So the body is not just a collection of organs, it is a system. Supply chain works the same way. A supplier is not alone. A factory is not alone. A warehouse is not alone. A delivery truck is not alone. A customer order is not alone. All of these parts are connected. If demand increases suddenly, inventory is affected. If inventory is low, procurement is affected. If procurement is delayed, production is affected. If production is delayed, logistics is affected. If logistics is delayed, customers are affected. And if customers are unhappy, the whole business is affected. That is systems theory in supply chain. It helps us see the full picture. Now, where did this idea come from? Systems theory is strongly linked to Ludwig von Bertalanffy, an Austrian biologist who developed general systems theory in the 20th century. He argued that many things in life should not be studied as isolated pieces. They should be studied as systems. A living organism is a system. A society is a system. An organization is a system. An economy is a system. And today, we can clearly say, a supply chain is also a system. Before this kind of thinking became popular, many businesses worked in separate departments. The purchasing team focused only on buying cheaply. The factory focused only on production. The warehouse focused only on storage. The transport team focused only on delivery. The sales team focused only on customers. Each department tried to optimize itself. But sometimes when one department improves itself, it creates problems for another department. For example, procurement may buy cheaper material to reduce cost. But if the quality is poor, production slows down. Customers complain, returns increase, and the company loses more money later. So procurement looked successful on paper, but the whole system became weaker. Another example, a warehouse manager may reduce stock to save storage cost. That looks efficient. But if demand suddenly increases, the company runs out of products, sales are lost, customers move to competitors, and the business suffers. So the warehouse reduced cost locally, but the full system lost value globally. This is exactly why systems theory matters. It teaches us that local improvement is not always overall improvement. A supply chain manager cannot only ask, how do I make this one department cheaper? They must ask, how does this decision affect the whole system? Now let's take a real-world example. During COVID-19, many companies had very efficient supply chains. They kept low inventory. They depended on a few suppliers. They used just-in-time delivery. They reduced extra stock to save money. On normal days, this looked smart. But when factories closed, ports slowed down, and shipping became expensive, those same efficient systems became fragile. Companies could not get parts. Shelves became empty. Hospitals struggled for supplies. Car factories stopped because one small chip was missing. This showed the world one powerful lesson. A supply chain is not strong just because one part is efficient. It is strong when the whole system can survive pressure. Systems theory also helps us understand feedback. Feedback means the system reacts to information. For example, if customers buy more of a product, sales data goes back to the company. The company orders more stock. Suppliers produce more. Warehouses prepare more space. Transport teams plan more deliveries. That is feedback. But if the feedback is slow or wrong, the whole system makes bad decisions. If a company thinks demand is high when it is not, it may overproduce. If it thinks demand is low when it is actually rising, it may run out of stock. So information flow is just as important as product flow. A supply chain does not only move goods, it also moves information, money, decisions, and risks. That is why modern supply chains need data, software, forecasting, dashboards, tracking systems, and communication between departments. Because if one part of the system is blind, the whole system becomes weaker. Now think about Amazon. Amazon is not powerful only because it has warehouses. Many companies have warehouses. Amazon is powerful because its website, customer data, inventory systems, warehouses, delivery network, sellers, packaging, payments, and tracking systems are connected. When you click Buy Now, the system checks stock. It decides which warehouse should ship the product. It creates a picking task. It updates inventory. It prepares delivery. It tracks the parcel. It informs the customer. That is not one department working alone. That is a connected system. Toyota is another example. Toyota became famous because it connected suppliers, factories, workers, inventory, quality control, and delivery timing. The company understood that production is not just about machines, it is about flow. If one part of the flow is weak, the whole system suffers. That is systems theory in action. So when we apply systems theory to supply chain, we learn a few important lessons. First, every part is connected. Second, one small problem can create a larger effect. Third, improving one department does not always improve the whole business. Fourth, information flow is as important as product flow. Fifth, a strong supply chain needs balance, not just speed or low cost. This is why systems theory is one of the most important theoretical perspectives in supply chain management. It teaches us to stop thinking in isolated pieces and start thinking in connected networks. Because in the real world, suppliers, factories, warehouses, trucks, store websites, customers, data, money, and risks all affect each other. So the simplest way to understand systems theory in supply chain is this. A supply chain is like a living body. If one important part fails, the whole body feels it. And now that you understand why everything in supply chain is connected, the next important question is, why do companies decide to make some things themselves, buy some things from suppliers, and outsource some things to other businesses? That question leads us to transaction cost theory. This is the Learning Studio, where we explain business, technology, science, and the systems that quietly shape the world.